myself Dr. G. Amjad Khan, Associate Professor, working in the Department of ECE, G. Pullareddy Engineering College, Kurnool. Today I would like to demonstrate on the working operation of the full wave rectifier with filter and without filter. Coming to the circuit diagram for a full wave rectifier, if you observe here, so 230 volts, 50 hertz AC supply we are going to give from the mains to the primary winding of the transformer, and if you observe the output of this secondary winding of the transformer, we are having 12 transformer, and here we are going to take two diodes, and the two diodes cathodes are connected at one end, and that end of the diodes is connected to positive terminal of the ammeter, and the negative terminal of the ammeter is connected to the variable resistance, that is potentiometer, and it is grounded. The output here we are going to measure using the digital multimeter. So this is the circuit diagram of a full wave rectifier circuit without filter, and if we consider with filter, here in addition to this circuit we are going to connect the capacitor across the load resistance. Here the positive terminal of the capacitor is connected to negative terminal of the ammeter, and this negative terminal is grounded here. So this is the basic difference between the without filter and with filter. Coming to the performance characteristics, if we observe, here we are going to find out the ripple factor percentage regulation of a full wave rectifier with and without filter. The filter which we are going to use a capacitor filter. Coming to the components, here we are going to consider PN junction diode 1N4007 2 numbers, and capacitor 1 number, CRO, ammeter 0 to 20 milliamps. So in place of decade resistance box, we are going to use a potentiometer, digital multimeter, transformer, breadboard, and connecting wires. Connections here. So we are going to connect the transformer here. This is the transformer. So the secondary windings of the transformer are connected to two diodes. So diode anode we are going to connect, and another winding here where we are going to connect to the anode of the diode, and this is a center tap transformer. So these two cathodes are internally connected, and from this here we are going to take the we are going to connect this positive terminal of the ammeter, and negative terminal is connected to the ammeter, which we are going to take 0 to 200 milliamps, and here this is the this internal, here we are going to use a capacitor here. If I connect this capacitor, it is with filter. If I remove this capacitor, the circuit is without filter. Now first I am going to observe without filter, and here, so this is a variable resistor, that is the potentiometer. Across this potentiometer, here we are going to connect the digital multimeter here. So this is connected to the volts, and this black terminal is connected to COM. And if you observe in this digital multimeter, here we are having this DC voltage which represents the constant line, and here variable sinusoidal signal is there. This is the AC voltage. So this red represents here, these red values represent AC voltage, these black values represent the DC voltage. Now the tabular column. So here first we are going to measure the no load voltage. This no load voltage can be measured by removing the connection of the potentiometer, and here load resistance we are going to calculate of the potentiometer. By varying the potentiometer, we are going to take the DC voltage, DC current, and the AC voltage. After finding out this, we are going to find out the ripple factor R equals to VAC by VDC. and then we are going to find out the percentage regulation, that is VNL minus VFL divided by VNL into 100. Now first I am going to measure what is the no load voltage for the full wave rectifier by removing this connection here. By removing this connection here, I am going to measure the no load voltage. One terminal of the potentiometer here, I am disconnecting this and measuring the no load voltage. It is 11.40. The no load voltage is 11.40 volts. After that, I am going to connect the load, and then by varying the potentiometer here, I am going to vary the potentiometer, and here by varying the potentiometer at different time intervals here, the DC current is 25 milliamps. The DC current is here 25 milliamps. The DC current is 25 milliamps. If I observe the DC voltage, it is 9.25. The DC voltage is 9.25, and by moving this here, the AC voltage is 4.7 volts. And here the ripple factor can be find out here. We can find out the ripple factor by finding out the ratio of AC voltage. AC voltage is 4.7 divided by VDC 9.25. So the ripple factor for this 0.50. The theoretical ripple factor of the full wave rectifier is 0.48. Theoretical ripple factor is 0.48. So this value is nearer to 0.50. And finding out the percentage regulation here, we can find out the percentage regulation VNL. So VNL is VNL value, what I am going to take is 11.40 minus VNL minus VFL. Here I am going to take the DC voltage 9.25 divided by VNL. So VNL is 11.40. If we find out this, we are going to get 0.188 into 100. If we multiply this, the percentage regulation is 18.85. The percentage regulation is 18.85. After that, if we want to measure the resistance, we can measure at the potentiometer. By connecting at the potentiometer, we can measure, and by these values also we can measure here. VDC value is 9.25 divided by the IDC value is 25. So 25 milliamps it is. So if I multiply with 1000, then it becomes 370 ohms. So the load resistance value is 370 ohms. So this is the procedure to calculate the ripple factor and the percentage regulation. Now I am going to vary the potentiometer here, and I am going to adjust this to nearly 50 milliamps. If we observe for 50 milliamps, the DC voltage is 9.11 and AC voltage is 4.7. The AC voltage is 4.7, and we can find out the ripple factor, percentage regulation and load resistance. So first I will take all the values by varying the potentiometer. So I am going to adjust this to 75 milliamps. So the DC voltage is 8.99. The DC voltage is 8.99 and the AC voltage is 4.6. 4.6. Again, by varying the potentiometer here, by varying the potentiometer, so it is the current is nearly 100 milliamps, and here if you observe, the DC voltage is 8.9 and the AC voltage is 4.6. AC voltage is 4.6. Again, by varying this to 125, the DC voltage is the DC voltage is 8.82 and the AC voltage is 4.64. Again, by keeping the varying the potentiometer, the current is 150 milliamps. The DC voltage is 8.7 and the AC voltage is 4.6. So after this we can do the calculations. So these are the tabulated values I have calculated. Now the load resistance is decreasing here, and if you observe the DC voltage, it is also decreasing with respect to the varying resistance. The DC current is increasing here. The ripple voltage is also decreasing, and the ripple factor is maintaining constant here, and the percentage regulation is going to be increased. Now coming to the graphs here, so here we are going to draw three graphs. The first graph is between IDC and VDC, with filter, without filter, and second graph is between IDC and the ripple factor, and the third graph is between IDC and percentage regulation. So first graph, if you observe here, as the IDC value is increasing, if you observe here the IDC value is increasing, the DC voltage here, the DC voltage without filter, it is decreasing here. The DC voltage without filter is decreasing. So we have got the exact values related to the graph. And the second waveform is here between the ripple factor. So ripple factor here remains almost constant. So without filter, we are going to get the curve, constant curve here we are going to get. And the third graph is between the percentage regulation and IDC. As the IDC is increasing, so there is a variation in the regulation. So without filter, the regulation is increasing. So these are the tabulated values and the graphs I have explained for the full wave rectifier without filter. Experiment continuation with the, we are going to observe with filter. So this is the capacitor which we are going to take here. So here I am going to connect the capacitor. So then it becomes the full wave rectifier without filter. Now here first I am going to remove the potentiometer one end, so that I can measure the no load voltage. So here for the full wave rectifier, if we observe the no load voltage, the no load voltage for the full wave rectifier is with filter is 15.09. So here I am going to note the reading 15.09 volts, and then by connecting the load, and by varying the potentiometer, once again here I am going to take the reading at 25 milliamps. The DC voltage is 14.32, and the AC voltage is here. Here the AC voltage is 0.04. So if you observe with filter here, the ripple components are reduced to a greater extent, and we can tabulate these values as we have calculated in the previous table: ripple factor and the percentage regulation and the load resistance. One value I will calculate here, the ripple factor value. So here the ripple factor value is R equals to VAC 0.04 divided by 14.32. So it is 2.79 into 10 power minus 3. So this value becomes 0. So this value becomes 0.0027. So in this manner I will calculate the percentage regulation. The percentage regulation for this is VNL. VNL is 15.09 minus VDC value is VFL is 14.32 divided by VNL, that is 15.09 multiply with 100. So here the percentage regulation is 5.10. So in this manner I will take the readings by varying the potentiometer here. So here I am going to vary the potentiometer and adjust the DC current to 50 milliamps. So in the 50 milliamps, the DC voltage is 13.8. The DC voltage is 13.8 and the AC voltage is 0.12. AC voltage is 0.12. Again, by varying the potentiometer and keeping at 75 milliamps, so the DC voltage is 13.5. The DC voltage is 13.5 volts and the AC voltage is 0.1. It is 0.1. Again, by varying the potentiometer and adjusting up to 100 milliamps, the DC voltage is here 13.2. The DC voltage is 13.2 and the AC voltage is 0.2. The AC voltage is 0.2. Again, by varying the potentiometer and keeping at 125, the DC voltage is 12.8 and the AC voltage for this is 0.2. AC voltage is 0.2 and the final value I am going to vary the potentiometer and adjust it to 150. So here the DC 12.4, the DC voltage is 12.4 and the AC voltage is 0.3. AC voltage is 0.3. So by taking these readings we can calculate the values. The values I have tabulated with the capacitor filter. Now the load resistance I have calculated and the ripple factor I have calculated and the percentage regulation we have calculated. So the ripple factor is reduced to a greater extent because with capacitor filter the ripple voltage is reduced to a greater extent when we compare without filter. Here the three same graphs here we are going to observe with filter. So if you observe with filter IDC value, the IDC value is increasing here and with filter the VDC value, so the VDC value is decreasing. And next the second graph is graph between IDC and ripple factor. So if you observe the ripple factor, so the ripple factor is slightly increasing, small variation is there. So here the ripple factor is slightly increasing, at some instance it becomes constant. And the third one is percentage regulation. So as the IDC value is increasing, the percentage regulation is also increasing with filter. Whereas there is a deviation in the percentage regulation without filter and with filter. So with filter, it is going to be reduced when we compare without filter. So these are the graphs and the tabulated values of the performance of a full wave rectifier with filter and without filter. Thank you very much.